We will begin by demonstrating gemident's ability to locate oranges in a photograph of an orange grove. To begin a new project, we choose a new project icon. We'll name it. Then we'll tell the program the directory where the JPEG file is located. Gemident supports many types of image sets. Since this is a single photograph and not part of a larger panoramic image split into many pieces, it's dubbed a non-global. The first step is color selection. We have to tell Gemident which colors are important to the analysis. Let's load up the image. The first important color will be the color orange, reflecting the fruits themselves. The second is the verdant green of the trees. Let's give some examples of orange. For contrast, I'm going to color our selections blue. Notice how the thumbnail image is updated. If we make a mistake, we immediately have feedback in the thumbnail. I can delete mistakes by using the middle button. Once we've given about 10 examples, we can solidify our selection by hitting Compute. Now let's train for green. Once again, for contrast, I'll color our selections red. We want to give a diverse example of green from light to dark. Now there are two other colors, blue for sky and tan for this dirt path. But since the sky nor the path are close in proximity to the oranges, they're not too important for our classification. So color training is now finished. We'll now proceed to the next step, training for the objects of interest. Objects of interest are dubbed phenotypes in Gemident. In this example, we have one phenotype, the oranges themselves. We will now train for oranges by explicitly clicking the centers of oranges. Once again, for contrast, I'll color our points blue. It's important to click as close to the geometric center as possible. I use the magnification window on the right for accuracy. We must also point out what the opposite of the orange is. We dub this pseudo-phenotype the non. Let's train for some obvious nons. For contrast, I'll color these points gray. That's probably not the best contrast. Let's change the color. Much better. It's also important to train just around the oranges so gemident doesn't get confused. It's important not to touch the oranges. Alright, we have 15 or so examples of oranges and about 80 examples of nons. I think we're done training and we're ready to classify. Gemident has now created a machine learning classifier. These are the relative importances of our two colors. The x-axis shows the distance of the color to the center of the oranges. It makes sense that low distances for the color orange are important, because oranges are colored orange themselves. It would also make sense that green is important at these distances, because oranges don't have any green inside. Gemident is now classifying each pixel in the image. We'll wait for it to complete. It is now resolving the pixels into centroids, which will give us a count of the number of oranges in their coordinates. That was done relatively quickly. So let's see how it did. We have 100 or so oranges, and it didn't make any mistakes. The diamonds represent a classified centroid, and the blue mass represents classified pixels. Looks like it did pretty good, and retraining won't be necessary. The coordinates of the oranges are written to a local file.